For years, the AI industry has been obsessed with one question: who has the smartest model? But as of this week, that is the wrong question. The new question is, who can actually execute the work?
Yeah, that's really the shift we're seeing right now.
Right. And welcome to the deep dive, everyone. We're jumping into your stack of sources today, specifically the July 12th, 2026 edition of your weekly AI Pulse. And I mean, our mission today is really to look at this massive industry shift. We are crossing this critical threshold where AI isn't just, assisting us anymore. It's actually becoming this execution layer that builds and coordinates and acts completely on its own.
Exactly. And if you're listening to this, the core theme you really need to keep in your head today is execution over intelligence. Because, I mean, for the longest time, your competitive advantage was just having the smartest standalone model, right?
Yeah, like who has the highest benchmark score?
Right, exactly. But that's over. The new competitive advantage is organizational readiness. It's
Hmm.
about, do you have the infrastructure to actually execute complex tasks autonomously instead of just chatting with a bot in a window?
Okay, let's unpack this because to really grasp this shift to execution, I feel like we have to start with software development. It's completely rewriting the rules there. Which brings us to Meta's big move this week. They just launched Muse Spark 1.1. And the sources make it clear this is not just another coding copilot.
Oh, no, not at all.
Like, it's not just auto-completing your Python. It's a full-on autonomous software engineering agent.
Yeah, it's a profound architectural shift. I mean, historically, the AI workflow was super transactional. So user gives a prompt, AI gives a response, you say write a sorting function, and it just writes it.
Right, so basically fancy search.
Exactly. But MoveSpark 1.1 uses what's called a react loop, so reasoning and acting. The architecture goes from user to goal, and then the AI actually plans out the steps.
Wait, so it comes up with its own roadmap.
It does. It plans, and then it delegates to subagents. It uses external tools, and then it executes. If the code fails, it actually reads the error log, reasons about the failure, and, tries again.
That is wild. And there's this specific detail in the sources about Meta's strategy here that I think is brilliant. They are combining this multimodal intelligence with super aggressive pricing, like $1.25 per million input tokens.
Which is just crazy cheap. And it's incredibly strategic because when an AI is in one of those React loops, it eats up a massive amount of tokens.
Right, because it's constantly reading logs and looping back.
Exactly. It's checking files, debugging, trying again. If you're paying premium token prices, an autonomous agent bankrupts you pretty fast. So by dropping that price floor, Meta is basically trying to capture the whole developer market.
You're making it cheap enough to let the AI just churn in the background. Which actually makes sense of this other massive story, the Swedish startup Lovable. I was reading this, and at first I was like, wait, why is Lovable growing so fast if Meta is giving away dev tools for basically nothing?
Right, it seems contradictory.
Yeah, but then it clicked. Lovable isn't selling to developers. They are in talks for a $13.2 billion valuation, and they just hit a $500 million annualized revenue run rate in record time. Because they're selling to people like me.
Exactly, the non-coders.
Right. I can just describe an app in English, and it builds it.
And that's what the industry is calling vibe coding. It's this rise of vibe coding where natural language completely replaces programming syntax. You don't need to know JavaScript. The barrier to entry is just gone.
Which turns, like, marketing people and product managers into full-stack creators.
Yeah. Anyone with an idea is a software creator now.
Which perfectly sets up our tool of the week integration, which is Manus. Manus takes this vibe coding idea and just pushes it into full workflow automation. You give it an objective, and it executes. But the sources highlight two things that make it actually work for
Okay.
companies, persistent projects, and MCP connectors.
Yeah, those are what take it from a parlor trick to an actual enterprise tool. So persistent projects, that's basically giving the AI long-term memory.
So it remembers what you did yesterday.
Right. You don't start from a blank chat every time. You store your brand guidelines, your instructions, all the context in a project, and every new task just inherits that automatically.
Okay, and what about the MCP connectors? The sources say it stands for Model Context Protocol, but what does that actually mean for, like, a regular user?
Think of it as the universal USB port for AI. Before, if you wanted an AI to talk to Slack and then pull data from Zapier or GitHub, you had to write custom brittle APIs for everything.
And they always break.
Always. But MCP is an open standard. It lets AI securely plug into your existing tools. So Manus doesn't just give you text. It actually reaches into your Slack or Salesforce, reads the data, and takes the action for you.
It's like traditional coding is like building a house brick by brick yourself, right?
Hmm.
You're mixing mortar and everything. But Lovable and Manners are like hiring an AI general contractor. You just describe the house you want, and they hire the sub-agents to pour the foundation and, run the plumbing.
That's a perfect analogy. You manage the outcome, not the syntax.
But I have to push back here
Yeah.
because, honestly, this sounds like an absolute nightmare for IT departments. If literally anyone in a company can just spin up massive software projects with one sentence,
Hmm.
isn't this going to create insane amounts of shadow IT? Like unmaintained apps everywhere?
I mean, yes, that is the immediate fear. You're giving everyone an infinite compute credit card.
Right.
But the flip side is that these agents can also read and document their own code. So instead
Yeah.
of a human writing a script and then quitting, leaving a mess, the AI can actually maintain it. But you're right. Governance and automated review are going to be the next massive enterprise hurdle.
Yeah, and there's a cost to all this, too. If millions of people are deploying these AI general contractors to run multi-step workflows, the compute power required is just going to skyrocket. So we really have to talk about the new AI economics, cost of intelligence.
We do, because you have to separate training compute from inference compute. Training is like studying for the final exam. It takes months, huge supercomputers. But inference is actually taking the test.
And agentic workflows mean millions of agents taking tests millions of times a second.
Exactly. And that inference cost gets astronomical, which is why Microsoft's new routing strategy is so important. They're introducing this intelligence router across Microsoft 365.
So how does that work? Does it just act like a traffic cop?
Pretty much. Instead of sending every single prompt to OpenAI's massive, expensive GPT 5.6, the router intercepts it. It looks at the complexity, the tokens, and if it's a simple task like fixing a typo, it routes it to their own cheap internal MAI models.
Oh, wow. So they save the big guns for the hard stuff.
Right. It only sends complex reasoning tasks to GPT 5.6.
Here's where it gets really interesting, though. If you play that out, models basically become commodities. If everyone has a decent model, the real power isn't the model itself, it's the router.
Bingo.
Like the orchestration layer that decides who gets the job, that's the real estate you want to own.
And that's the infrastructure war we're seeing right now. It's all about inference. I mean, look at Samba Nova from the sources. They just raised $1 billion at an $11 billion valuation.
Which is huge for a hardware company not named NVIDIA.
It is. And they aren't even building traditional GPUs. They have this new SN50 chip based on an RDU architecture, a reconfigurable data flow unit.
Wait, how is an RDU different from the GPUs everyone already uses?
So a GPU spends a ton of energy just shuffling data back and forth from memory. It's inefficient for AI inference. But an RDU actually reconfigures its physical pathways on the fly to match the exact mathematical shape of the AI model.
That's incredible. So the data just flows straight through.
Exactly. It radically cuts latency and power. And they just partnered with JP Morgan Chase for secure on-premises AI inference because banks don't want these agents running in public clouds.
They want it in their own basement. And speaking of power, there was this wildcard idea in the sources about Sunrun, the solar company. They're exploring distributing AI compute nodes into residential homes using solar and battery power just to bypass the data center energy bottleneck entirely.
I mean, it sounds crazy, but the logic is completely sound. The grid can't handle the data centers. So if you put small servers in homes where the power is actually being generated, you bypass the grid completely.
It's wild. But it really highlights how desperate the industry is for power to run this execution layer. But, as AI executes more software and operates on this huge distributed infrastructure, the risks skyrocket. We have to talk about trust, truth, and the physical world.
Yeah, because when AI is just a chatbot, a mistake is just funny. But when it takes on autonomy, trust becomes the most valuable commodity in the world.
Right, and we're seeing the corporate responses to this trust deficit. Like, Google is now requiring disclosures for ads made with generative AI, and then there's Meta's big misstep from the sources. They launched that Muse image feature on Instagram.
Oh, right, the one they had to pull.
Yeah, it let you reference public accounts to generate new images without even notifying the original account holder.
Yeah.
And the backlash was so bad, they basically deleted the feature overnight.
It's a perfect example of what we call the consent gap. It's this friction between what the tech can technically do and what users actually believe they agreed to. Just because a photo is public doesn't mean you gave permission for an AI to clone your identity.
Exactly. Accessible public data does not equal permission. But because trust is breaking down, we're seeing this massive need for verification infrastructure. The sources mention a company called Savi.
Yeah, Savi's fascinating because they're trying to protect against AI scams at the source. For years, we tried to build deepfake detectors, but the AI always outsmarts the detector eventually.
It's a constant game of cat and mouse.
Right. So Savi uses cryptographic verification. It embeds secure metadata into the content the second it's captured by a physical camera. So you don't have to prove it's fake later, you just mathematically prove it's real from the start.
Which is so necessary as AI meets the physical world. And that brings us to Anthropic and UST. They had this partnership where Claude is actually moving beyond software and into physical environments.
Yeah, UST is using Claude to validate semiconductors, to monitor telecom networks, and even operate in heavy factory environments.
Okay, think about this for a second. When an AI is monitoring a telecom network or a manufacturing plant where a mistake can cost millions of dollars, how do you actually trust it? Like, a hallucination in a factory could be catastrophic.
It's the biggest question right now. And the answer the industry is using is called the human-in-the-loop architecture.
So humans are still involved.
Absolutely. The AI observes the vast amount of data, which it's great at, and it recommends a specific action. But a human engineer has to actually review and approve it before the system executes. The AI analyzes, the human authorizes.
So the human is basically the ultimate safety switch.
Precisely.
Okay, so bringing this all together, we've got Meta building autonomous React agents, Lovell turning everyone into vibe coders, Microsoft routing models to save compute, and AI moving into physical factories. The big takeaway from all these sources is that our core theme is spot on. The competitive advantage is no longer just model access. It is organizational readiness and execution capability.
Yeah, and if we connect this to the bigger picture, the Pulse prediction for this week is that within just a few years, AI orchestration platforms, those routers and agent managers, they are going to be the central enterprise control layer. They'll manage everything from basic chatbots up to autonomous physical systems.
It really is a new era. And as we move into this age of execution over intelligence, we have to leave you with one final thought. When an autonomous AI agent acts on its own, say, it hallucinates a bug into a bank's code base, or makes a critical error in semiconductor validation, who actually holds the legal and financial liability? Is it the user who typed the prompt, the model creator, or the orchestration platform that routed the task? The technology is ready to execute, but our legal systems haven't even written the job description yet.
It's a huge unresolved question.
It really is.
Yeah.
Well, thank you all for joining us on this deep dive. If you want to keep exploring these shifts, make sure you subscribe to the newsletter and leave a comment. Until next week, stay innovative and AI-powered.